Our final point here in this module where we're introducing organic chemistry is that structure determines function. And this is a massive theme in biochemistry where we're pretty much making molecules with the same building blocks. And if we're using all the same building blocks, then what else could determine the function, right? There's no difference between carbon here and carbon there. It's the structure of the molecule and how we arrange the building blocks that determines the function of that molecule. And its primary function is determined by its functional groups, but it's also determined by its overall size and shape, which can lead to polarity. So structure determines function. We're going to see this a lot in the rest of the course as we look at macromolecules like carbohydrates and proteins and lipids. And for now, just, have faith that this is a really, really important theme in chemistry. And so, as we want to look at a structure and say, oh, structure determines function, a big part of that structure is the functional groups. So take a look at this one and see if you can spot some of the functional groups that are present in this molecule aspirin. Try to name them as well as identify where they are on the molecule. So go ahead and pause here and see if you can do it. All right, hopefully you were able to identify some functional groups by name. The first one is here we have a carboxyl or carboxylic acid group, that's that COOH. And over here we have this ester linkage where we have the COO that bridges along what would be an unbroken carbon chain. Imagine that we just replaced all the oxygens here on the ester with carbons. It would just be continuous carbon. This ester is basically sitting in the chain of carbons that if it were unbroken would have no functionality. Because the ester is here, it has some functionality. Okay, what about these two? We have ibuprofen and novocaine now. We want to identify the functional groups on these. So go ahead and pause again and see if you can identify them. All right, so on ibuprofen, how many functional groups were you able to find? I only see the one. It's this carboxylic acid group. Everything else is hydrocarbon. And if we did see like a lone double bond or a lone triple bond, we might want to call that an alkene or an alkyne. There is this benzene ring in the middle, right? This 6-membered ring with the alternating double bonds. But that one, I don't know if we really want to consider those functional groups in the same way. It's there, it's present, it's obvious, and it does determine some of the behavior of this small molecule. But as far as functional groups, carboxylic acid is what we have. And on the novocaine, we have an amine, so this is that H2N, the nitrogen containing, basically nitrogen replacing a carbon, especially at the end. We have an amine, and we also have another ester, so this ester that links these together. And this gives us novocaine. The other nitrogen on the other side, I don't know if we really want to consider that one an amine in the same way. You really want to have nitrogen bonded to hydrogen to consider it an amine as far as functional groups for this course. But that nitrogen may have some behavior that's related if you look and see other similar derivatives moving forward. Again, for organic chemistry and what we want to know here, we have the building blocks to start looking forward toward macromolecules. This is a vast field of chemistry where you could be a synthetic chemist to figure out how to build these small molecules. There are 2-semester courses on organic chemistry that will discuss the various reactions to grow molecules, to make molecules, to develop targets for other molecules. I mean, it is really very complicated. And for this course, identifying some common functional groups and appreciating that functional groups determine what a molecule can do and its role as a therapeutic or a drug or something like that is what we're looking for.